Hello everyone. In this video, I am going to show how to extrude a blood vessel with irregular cross section to a perfectly circular cross section. As you can see, uh, the cross section of this particular uh, end of the blood vessel is not a perfect circle but something irregular. So we would like to extrude this blood vessel to a perfectly circular cross section. For that, the first thing we need is a curve at the end of the blood vessel, which we can get by running the repair geometry option. In that, we'll select the build diagnostic topology and click apply. Once the process ends, we'll have a curve at the end of the blood vessel. Next thing, we'd like to create a local coordinate system at the end of the blood vessel so that we can extrude the blood vessel in a direction which is perpendicular to the cross section of the original end. For that, we'll need 3 points at the end, and let's create 3 points. We'll select the create point option, go to the screen select option, and the first point that I'm going to create will be approximately diametrically opposite to the point which is already present on the curve, somewhere here. And another point that I'm going to create is somewhere to its right. Once we are sure about the position of the points, we can confirm it by clicking the wheel button of the mouse. Once that is done, the points are finalized. Here we'd also like to have another point just between halfway between these 2 points, and that point will serve as the origin of the local coordinate system. For that, we'll select the option based on two locations and keep the method to parameters and the parameter value to 0.5 and select the 2 points between which we want the point to be created. As soon as we select the 2 point and confirm, we have another point, and this will serve as the origin of the local coordinate system as well as the approximate centroid of the cross section of this irregular cross section. So first of all, let's create the local coordinate system. We'll keep the method as 3 points and let's select the 3 points, starting with the point which is supposed to lie at the origin. So this is the point. Second, we'll select the other 2 points. As soon as we select the 3 points and confirm the selection by the pressing the wheel button of the mouse, we have created a local coordinate system. As you can see, the y axis of the local coordinate system is perfectly perpendicular to the original cross section, and we would like to extrude this particular end of the blood vessel in the y direction. Since we want to extrude the blood vessel to a perfectly circular cross section, it would not be able we would not be able to create such a extrusion if we just translate the original curve at the end. In that case, it would be extruded, but the final cross section would be similar to the one we have now. For that, since we want the extrusion to a perfectly circular cross section, we'll have to create another curve which is perfectly circular at some distance along the y direction. In order to have a circle, we can use this option which says circle or arc from center point and 2 points on the plan. The 2 points are in the circumference of the circle, but for that we need 3 points to begin with, but we don't have 3 points. So let's create 3 points at some distance along the y-axis. We'll go to create point and select the option explicit coordinates. As long as the local coordinate system is turned on, every the values of the coordinates that we insert here will be according to the local coordinate system. So this makes uh, it easy to create the points at the desired location. Let's say we want to create a point, the center of the circle at 30 units away from this cross section. So we have put 30 and just click apply. So we have created the first point. Next, we need another 2 points on the circumference of the circle to be created. But at this point, we do not know the radius of the circle that we want to create. So for that, we'll use the information of the surface area of the original cross section. As of now, we do not have a surface at the end of the blood vessel at its original end. So in order to calculate the surface area, we'll create a surface first. Go to the create and modify surface. Select the simple surface option. Go to from curves. Select the curve and confirm by clicking the wheel button of the mouse. As soon as we do that, we have a surface at the original end. We can delete it later when we do, if we do not require it. Now we can calculate the surface area by going to the info option. Go to surface area and select the surface for which we want the information and confirm it. As soon as you confirm it, we have the surface area of 185.22 square units. Now since we have the surface area, we can create a circle having the same surface area. For a circle to have for a circular cross section to have the same circle area, same cross sectional area, the radius comes out to be around 7.68 unit. So we will use that as the radius of the uh, circular curve that we want to create. So let's do that. We are left 2 points remains to be created. 2 points remain to be created, and 1 point, the origin of the circle is already created. So let's create the other 2 points. 7.68. This is the first point on the circumference of the circle to be created, and we need another point, 7.68. So thus we have now 3 points, one at the origin, center of the circle, other two at the circumference. So let's create the circle. We'll go to create and modify curve, select this option, select the center first and the 2 points on the circumference, and we have a circle. Now ideally we would like to connect these two curves and create a extruded surface. So let's do that. For that, we'll go to the option of create and modify surface. Click this option of loft surface over several curves and select the two curves and confirm. As soon as you confirm it, we have a extrusion. At this point of time, we may like to delete the surface at the original irregular cross section. For that, we go to the delete surface option, click the surface that we created just for the sake of calculating the surface area, and confirm it to delete it. That's deleted. And also we would like to close the end of the circular cross section that we have created just now. For that, we'll try using the option of simple surface and form curves. We'll keep the method to form curves and select the curve at the end and confirm it. Once you confirm it, it shows that it is done creating a surface, but we cannot view any surface. It's not visible. So let's try the other method from 2 to 4 curves, and select the curve at the end once more, and this time it closes it. So this is done. So just like that, we have created a extrusion with a perfectly circular cross section. At this point, if we want, we can delete the curves that were created as a part of the extrusion, like this one, and maybe this one. Before finishing off with the video, sometimes it might so happen that the extrusion doesn't uh, happen perfectly. One of the issue with ICM CFD is that even the closed curves, like the circular one or the curve that is with the irregular cross section, there is a starting and end point. For example, the starting and end point of this particular circular curve is this point, and the starting and end point of this irregular curve is this point. So luckily, in this demonstration, it so happened that these two parts are aligned properly, and we get a perfect extrusion. But even if we look at it carefully, we can see that those are not that line is not perfectly okay, and it has a slight inclination. If we want to correct that, we can do that by changing the start and the closing point of this circular cross section, and align it perfectly with the start and the closing point with the irregular cross section. For that, would like to uh, project this point on this curve and create a new circle. So let's do that. Would delete the surfaces that we have created just now, and the extruded surface as well. Let's delete the curve that is created as a part of the extrusion, and delete this point on the circle, which is acting as the start and the closing point as of now. That is gone. Now we would like to now we would like to project this particular point to this curve. For that, we would go to the create point option and select the project points to curves option. First of all, we have to select the curve onto which we want to project the point. So this is the curve. Select it, confirm it. After confirmation, we have to select the point which we want to project. This is the point we want to project, and click OK. Now we have a point on this circular curve which is perfectly aligned with this point. At this point, we would like to create this circle once again with this as the starting and the closing point. So delete the circle and go to the create and modify curve once more. Select this option of creating a circle or arc from a center point and 2 points, and create it once again. We'll start with selecting the center of the circle, and the next point is something important which has to be kept in mind. The first point that we select on the circumference becomes the starting and the closing point of the circle that will be created. In this case, we want this particular point which was projected just now to be the starting and the closing point of this circular curve. So we will select that first, and then the second one, and just like that we have a circular curve. Now if we connect these two curves and create a extrusion surface, the it will be perfect. So let's do that. We'll once again go to the loft surface option, select the original curve and the circular curve created just now, and select it. So this time the curve is perfect and there is no distortion, and we are good to go. And finally, will close the end of the created extrusion. We'll create the simple surface option, select the curve at the end and confirm. So we have a closed end, and also we'd like to delete the curve that was created as a point as a process. So let's do that, and the curves, so those are gone, and we have a perfectly circular we have extrusion with a perfectly circular cross section. That's all. Thank you.